Welcome to Artificial Intelligence in Test Automation. And it's AI, AI, AI. There's virtually no chance that you have not heard about AI at this point in time. It's revolutionizing driving, our lives, and yes, even testing. My name is Tobias Müller, and I'm the Managing Director of Progile. And for full disclosure, we are the vendor of TestResults.io. It's a test automation platform to close today's gaps in test automation. So in the beginning, there was a lot of chatter about AI because of Tesla's self-driving cars. People started to talk about machine learning, followed by deep learning, even though they didn't know the difference. Lately, you hear a lot about Gen AI or generative AI. Again, everybody's talking about ChatGPT and GPT-4, not so much about Tesla anymore. So there's one hype after another for artificial intelligence, and each of these new buzzwords seem to land directly in our software testing land, which makes sense, as the testers should be ahead of time. So today we don't talk about general AI or doing a product demo. So I'm not going to show you how to enter text in ChatGPT's prompt. Today we try to identify why AI is required for testing, look at where it can support us and go through examples specific for testing, go through buzzwords, and see what is AI and what is not in today's market landscape. So specifically in testing, it seems like everything is AI these days. And I'll show you a perspective on autonomous testing that is trivial, but in a way eye-opening as well. Before we do all this, let's set the stage and do a quick reality check, right before we dive into AI in test automation. So I assume most of you have a driving license. And how many hours of practical driving lessons are usually required to get such a license? I can only talk about Switzerland and Germany, but it's roughly between 16 and 20 hours. Then you do a test, and then you go. The road is all yours. You can drive everywhere and in every country, being it driving on the left lane or on the right lane. And now think about Tesla's autopilot. By 2018, Tesla had more than 1.9 billion miles of training data. And in 2018, Elon Musk promised full self-driving features by August. It's 2023 now, and let's see what Tesla says about FSD today. The hardware is capable of full self-driving, the software is not. In summary, 5 years are gone since 2018, and there are still no self-driving cars that go faster than 40 miles per hour in all weather conditions. So you might ask, why is that important? And I don't want to talk about Tesla, but it gives you a good relation. After more than 1.9 billion miles and more than, let's say, 9 years of teaching the AI, there is still no self-driving car. A car that can do what you can after having a lesson for 20 hours. And compare that to software, for which you as a human require multiple days or weeks to comprehend how the system actually works. I mean, you as a tester know it best, how much time you spend on learning the software inside out. And if you take the self-driving car problem now as a baseline, you can imagine how far we are away from AI-driven autonomous testing. It is far. But that's not all. I'll show you towards the end of the talk what the FDA requires as the entry point for every software in the medical field, which actually might make you think as well as in terms of autonomous testing. So let's go one step back. Why are we even looking at AI? And it's always the same. We are looking at the next best technology because either our problems are not solved with the current generation of technology, or the current one solved all problems but generated new ones. In summary, we want something fresh. Look at the poor TV there. If you think about automation in testing or test automation, whatever you call it, what are the main challenges? Besides a myriad of smaller problems, like keeping up with updated frameworks, keeping track of test environments, and large problems like test data, generating test data that is realistic, that is mapping the realistic data without a link to the realistic data. I've identified 3 problems that I see repeatedly in my daily business. The first one, I guess, is well known to all of you, and Bas just mentioned it as well, is flaky tests. So sometimes the test passes, sometimes they don't. And without any change to the subject on the test. That is more or less what he said as a false positive. So we know that the subject on the test reacts the same from a functional point, but might differ from a performance point. The web page took a bit longer to load. The typical example here are the wait or sleep statements. And the wait was a bit too short. The network latency is higher than usual. I'm pretty sure you've seen all this already. Or another example, the page generator of your CRM tool created new code. The web page still looks exactly the same, but the div structure is completely different than the last time. So after the update, all the divs are completely different structured. The next challenge I see is technology dependency. So for every platform, there's a different framework. On every platform, there is software that doesn't adhere to the standards of that platform. And it needs workarounds to make it testable. All of this special code needs to be maintained, otherwise we end up in broken automations again. So the real problem is not the dependency itself. The real problem is that we have to do more and more maintenance. More frameworks to maintain, more tests to adapt to changes in the underlying framework, etc. And this brings me actually to my last problem, the expert availability. The amount of software, of digital products is increasing. There are just not enough testers in the future, or perhaps already today. And replacing testers with test automation didn't help much in terms of expert availability, as most automation, as you know, it is not stable enough. I've seen multiple times, once the people in charge left the company, the automation got more and more useless, and the quality of the product got worse, as only testing stopped, but not development. And at some point, the automation was restarted from scratch by a new hire. And I guess we all experienced that. Perhaps you've even been a new hire. And now comes AI. Think about the mutation testing. Forget all about that. You have AI. It will find all of the problems. That is actually the advertisement that claims that AI can solve all of these problems, and we end up with fully autonomous testing. Everything is tested in a perfect way without us doing anything. And we make it simple. We don't talk about the levels of autonomous testing. Think about it, because there's a scale of levels of autonomous testing, as it's for autonomous driving. But that is already marketing per se. So if there is a kind of autonomous testing, it must autonomously test, and not like halfway with human interception, and we call that autonomous testing level 2. That doesn't make much sense. So either it's autonomous or it's not. Let's take a look at testing to understand how AI could actually help. We look at the 3 stages of testing. And yes, I made that 3. Sometimes you'll see 4, sometimes 5. I like to have small sets, so it's 3. The first one is design. So that includes everything we usually do to have a plan. In testing, we plan what we do. We define our goals. We define a strategy. We explore the software. We write test cases, or we note down test ideas. In other words, we prepare everything for a successful execution. And from an AI view, we do a lot of creativity work. And that sounds like it's meant to be for Gen AI or generative AI. So everybody's talking about that GPT-4, which is marketed as being uber creative. And let's see if that holds true. The next one is execution. So I am personally coming from an extremely regulated environment, and execution meant execution of test cases, which is interesting the first time, the second time, and perhaps the third time. But at some point in time, it is not fulfilling anymore to execute those test cases. So it's not much about creative work here, but it's more about precise work. At our first customer, test cases were required and they had to be written in a way that someone freshly hired from the street could execute them without prior knowledge of the software. There are more creative ways in execution, specifically if you do exploratory testing. So you have your testing ideas and you explore the product. But as this talk is about test automation, I assume the execution part is the one that everybody is trying to automate first. And naturally, there are a lot of problems here as well. Like the well-known flaky test cases that Buzz mentioned, which will never happen again with AI. They make you believe. Let's see if that holds true. And the last is, after we designed and executed our testing, we want to get learnings. So we investigate our test results, add perhaps a few more tests to get more clarity on specific behaviors, and we are ready to generate value by showing potential risks. Nothing else is testing. Testing is more or less like about, I want to identify the remaining risk in my software, in my IT process. And you want to give insights that otherwise only a customer could give to the management. And again, they make us believe AI is perfect for a lot of data. Let's see if that holds true. And you waited for it, and here it comes. Artificial intelligence, which, by the way, was already a hype in the 1960s, and another one in the 1980s when expert systems and Lisp were hyped. And the current hype started around 20 years ago. I think the most intriguing part of AI, at least that is what I get in all my discussions, is the perception that artificial intelligence rebuilds human intelligence. And we all need to understand that it's still only algorithms. And usually now everybody yells at me that the human brain also works with patterns, models, and programs. And that is, as far as I know, the currently accepted state of science. But most of those we don't really understand. We don't even understand the brain development of a 3-month-old baby. And from observation, we know that there are phases of growth in which more complex patterns are established. But that's just the observation of the result. That's not the understanding on how that process works. And I mentioned that because I want to map artificial intelligence against another class of algorithms, genetic algorithms. And if you hear the term genetic algorithm, no one would ever compare genetic algorithms to the way how humans reproduce, to say it politically correct. But that is more or less genetic algorithms. We copy nature. So we have a fitness function which allows us to evaluate how good a result is, and we always use the 2 best results to generate an even better one, in simple terms. And as mankind survived because of adoption, we implement some randomness to unblock us from local optimum. And that's actually perfect. We've just rebuilt Darwin's theory of the survival of the strongest. For AI, it's completely different. Everybody that used ChatGPT thinks the answers are better than the answers from a human, somehow completely neglecting that this is just statistics. And yes, my PC, even my phone, is far better in calculation than I am. Do I think it's superior? Yes, in that area it is. Math is defined, but life is not. So AI is still math, and it's not about being a human. So don't get me wrong, I love the solutions that AI brings, and I love the math behind it. What I think is a bit strange in that area is the perception. If you look at this, machines will be capable within 20 years of doing any work a man can do. If you look closely into the wording, you know exactly what will be coming in like the next few seconds. Think about that. That is exactly what you read on LinkedIn now all the time. AI will replace me. AI will replace this job. AI will be better than you. You will lose your job because of AI. AI will take over the world. And you know what? Exactly. This is from Herbert Simon from 1965. So that is what they thought in the first hype of artificial intelligence. Again, machines will be capable within 20 years of doing any work a man can do. And by now we know that's not the case. In 1965, they thought exactly the same as what you can read on LinkedIn in 2023. That said, before we look at AI or non-AI techniques that are sold as AI or autonomous testing, let me ask you this. Did you ever ask a vendor that talks about how AI improves test automation? How they test the AI? How do they actually test their product? So they implement AI in their test automation tool. How do they test the AI that it really works? So in this state of all problems fixed, did you notice that there is no testing tool out there that actually claims to be able to test AI engines? Sure, don't get me wrong. Some claim they can test a chatbot, but not the full underlying AI model. And let me ask you this. If nobody tests their AI, and again, it's just algorithms, how can we trust the AI in the testing tools to be able to test? That's a bit about the guarding from bus, isn't it? Like you write an automated test, but the thing is, who is testing the test? So if we claim now that AI can do the human job, how do we actually prove that the AI is capable of doing that without understanding how to test AI? It's actually an interesting dilemma. And it's also interesting that by definition, AI has a percentage of accuracy, which is always less than 100%. So it's never 100%. It will never be perfect. So you have false positives built into your testing system if your testing system uses AI or not. And that's the point that Bas spoke about. It's like having false positives is a problem. And his guarding makes sure that you identify those test cases that can be flaky and ensure that you cover all of the other passes. But introducing a system that is, by definition, not 100% accurate, introduces exactly flakiness. The interesting part on that is I've seen examples from a vendor where they actually test an image classification AI. And that was interesting. So they did it like this. They had 7 images of gears, small little gray gears. And they expected that the AI under test identified all of them as gears. And that's not how we should test AI systems. That is exactly how the model is already tested with accuracy and precision. So we always have a training and a distinct test set. And as long as I see examples like that, I see AI in test automation as a buzzword. But let's get into our AI and test automation examples. All of them real life examples. So I stole some screenshots from vendors and made sure to remove or blur vendor product names and logos as best as I can. And keep in mind, once more, all I want to do is to make you aware that AI might be a good tool, but most of the current adoptions don't bring real value to the table or even are not AI at all. So let's take a look at that. The first one is from a testing tool that claims to support autonomous testing. And now think about what autonomous testing actually means. That means I have a piece of software that can test another piece of software without any knowledge about it. Or with pre-trained knowledge, but at least I do not need to train it. It's like sitting, if full self-driving in a Tesla would work, I would sit in a Tesla, program the route, and there you go. But what's interesting about that is actually the claim. If you look at the slide, it's like they plot the use cases, so more or less like the coverage, the functionality coverage, against the value of the testing and the risk of the functionality. So what you see is like in the first, let's say 20%, it might be 18, in the first 20%, there are human written tests. So they cover 20% of the risks, but they are the most valuable tests of all of them, and they cover the highest risks. That's exactly how you start with testing. You want to make sure that you cover the highest risks and provide the most valuable feedback. And now you look at the rest of it. It's like 20% of that is already around 200 test cases, if you look at the 1,000 use cases at the bottom. The rest is AI-generated regression tests and AI-generated autonomous tests. And as you can see, the regression tests, the risk of those functionality is already reduced, and the value of those tests is also reduced. And last but not least, these autonomous tests that are generated by AI, and by the way, I get to the point where how those tests are actually generated. But this last bar at the bottom, if you think about it, it adds the most burden to the set. So afterwards, you have 1,000 use cases, 1,000 test cases, 1,000 possible results, but they add the least value and they cover the least risk. And think about that. So we use some kind of test case generation tool just to overload our pipeline. If you think about that, if 1% of those use cases is flaky, you will have 10 test cases or 10 use cases every single time you execute them with a result that is wrong. 10, every single execution. Doesn't sound much, but it's only 1,000 use cases. So if you continue with that, you will have a lot more use cases, and that makes a lot more flaky test cases in the end. And again, so you added a lot of test cases, but the benefit of those added test cases is rather close to zero. But you added a lot of overload on the interpretation of those test results. Now the interesting part is like, how does the AI actually generate autonomous tests? So again, that means tests that you do not need to interact with, that you do not need to code, that the software will automatically identify. And I have a fancy effect here because it's a fancy approach. That is an output from a software like that. And they test the website. And what you can see is more or less a sitemap. If you think about it, the whole AI is more or less like a crawler that goes through the whole site and tests for all of the references in there. And it's interesting, if you look at those points, how many use cases were generated. And now think about it. It only followed the links and the buttons and all of that stuff. It didn't exercise stuff like changing values in dropdowns. Think about the following scenario. If you have a little form where you do have a drop-down of, let's say, like 10 options, and you have 3 additional entry fields. So you have 10 options in the beginning. All of those 3 entry fields you should test at least with no entry, the wrong entry, partial entry, correct entry. So 4 other options per entry field. So that is 10 times 4 times 4 times 4. That is 160. That is roughly 600 tests already with just a small form with 4 fields. And what benefit do we have? And that's the problem with AI-generated test cases. It's like, it's the same as a model-generated test case. It's like, where does the software know from what is a useful test case and what is not? The thing is, what this software assumes is the same that property-based testing assumes. And I don't know if you know that. Property-based testing is something that is used in unit testing, where you say, like, I can define the properties of an algorithm, and then based on those properties, which are 100% correct, I can generate all of the tests that can test the algorithm. And this approach works, definitely. The only problem is, it's just a research problem. Because if you know all of the properties of an algorithm, you can also implement it perfectly. You can do a perfect implementation of that algorithm because you know all the properties. And that's exactly the problem on property-based testing, is like, it is based on something that you provide, but you know exactly that requirements are never complete. So you will never know exactly in the beginning what is a complete set of requirements and how to interpret the set of requirements, actually. But the software, so like if you do have an AI bot that walks through your software, assumes that the software that it finds right now is perfect, and it's not. So it cannot distinguish between what is a bug and what is no bug. And we'll get to that in a few minutes again, where you see that that is actually a problem in general. Let's continue, and I'm pretty sure you've seen that multiple times already. The proclaimed self-healing. So you all know selenium, you know Appium, and you know the selectors problem, like CSS selectors, XPath selectors, whatever, they break because the structure of the web page changed. Not a big deal. And since a few years, there are self-healing algorithms that proclaim that based on artificial intelligence, they will find the correct CSS selector or XPath or ID for the changed element, which is still the same as the one that we originally wanted to test. And I found that is a really interesting idea, having a self-healing test case. If you think about it, in testing, we do have an expected result, and we want to see if the actual result is compared to the expected result. So we do have some expectation on how the real world interacts. It's just a model. But based on that expectation and on our model, we see that if the actual result, so if the result of the real world matches to what we propose based on the model. And now you have self-healing. How does that fit into testing? How does something like that fit into testing? If so, the test case adapts to changes in the software, but how does the test case actually know if that change is correct or not? And you might know that from Applitool Eyes, they do have a kind of approval workflow where you have test cases and you need to approve all of the different changes in those screenshots. So if it's something like that, it works out because you as a human still interact with the software. You still do the approval. So what the system does is actually it finds deviation and says and tells you as a tester, hey, there's a deviation. Do you want to, and that is the element that I found. Do you want to approve the deviation? That's perfect. But that is not what self-healing in marketing actually proclaims. They claim like, hey, we do have this fancy artificial intelligence algorithm that actually identifies all the elements correctly after a change, completely autonomous. Let's check if that holds true. So I found a library for Selenium that proclaims to be a self-healing library. And you know the problem, you might not find elements and you get the no such element exception. All of that is fine. And it says like, it is an AI-powered open source library that improves the stability of Selenium-based tests and handles changes of updated web elements automatically, blah, 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 using a self-healing mechanism. And then it says under the hood, it uses a type of machine learning. And again, keep in mind, machine learning is something from the category of algorithms that falls under artificial intelligence that analyzes the current web page for changes. The modification of the longest common subsequence algorithm will wait. So it's an open source library. I went to GitHub and went through the code and looked at all of the implementations. And the only thing I found was actually LCS, a longest common subsequence algorithm implementation. Like that's exactly what they claim here. The only problem is like, that has nothing to do with AI. The LCS solution is dynamic programming. So that's coming from the graph theory, and it has nothing to do with AI. So I went into a discussion with the vendor and asked them like, hey, did I understand that wrong? How does your library actually work? Because if you say you use LCS to solve the problem, that's not AI. So where does the AI part come in? I went through all of your source code and I didn't find anything that I would classify as artificial intelligence coming from a university background. And the answer was like, nah, we do use LCS with a MySQL database to store the state. So they store the current state of the web page, and then if they need to do analysis of the changes, they store the new state of the web page. And based on those two sets that they stored in the MySQL database, they do a longest common subsequence algorithm execution. And said like, hey, that is self-learning. And the thing is, all of that is marketing bullshit. And sorry for my French. It's still just dynamic programming. There's no learning. It's just you're saving different states and you're using dynamic programming on different states, on different graphs, to see what is the longest common subsequence. And that's all. So it has nothing to do with AI. It has nothing to do with machine learning. It has nothing to do with specific part deep learning within machine learning. And it is nothing that you can actually prove that will work, because it just matches to the best match that it can. And it might be a completely different element. And it doesn't learn. So you cannot train it and tell the system like, no, that match was wrong. The correct match would have been this, so that the algorithm actually learns. No, it's a static implementation. I know it's called dynamic programming, but it's a static implementation of an algorithm that does not learn. And therefore, be careful with what you see and where people actually claim there is AI involved. One more example from something else that is actually a portal that combines all of the results that you have from automated testing, and they use a TF-IDF vector. So TF-IDF stands for term frequency inverse document frequency. And that is actually a statistical function, or let's call it a vector, that we use in artificial intelligence. So that is something that is actually from the category of artificial intelligence algorithms. What does TF-IDF do? So TF-IDF is more or less an explanation of finding the most likeliest document based on the frequency of a word. So based on the frequency of the word, you can identify in which of a million documents it is most likely to find that word. And that's pretty clever to use that, actually. So it's a value that you can use if you use stack trace, and that's exactly what they do. So what they do, if the software crashes, they analyze the stack trace, remove some dynamic data, and still have a stack trace afterwards, and then use TF-IDF together with Elasticsearch to actually identify if the problem has been seen before. So you train the system as the tester, you train the system if there is a failure in the test case, you see if that is really a test case or the subject on the test, and then you actually classify that and you can give it the module information and stuff like that. So you can add a lot of information to the failure. And you do that over multiple iterations. And the system will actually learn, like, if I find this stack trace, and more or less like what it does is, if I find this combination of terms, of words, how likely is it to match to any of the ones of the stack traces that are already identified or categorized by the tester beforehand? And the assumption behind that is that you can automatically identify errors as they happen based on the past knowledge of those errors, which is a brilliant idea, and which you would actually assume that it works. And it is AI. So for the first time ever, you can really claim that that is something coming from the AI research field, if you have a university background. But the problem is it doesn't take into context how programming works. If you code, if you are a programmer, one of the main tasks that you have besides inventing functionality is maintaining functionality, and that means refactoring. So what you do is, if you see any problems and you have your unit tests and stuff like that, but you clean up. That's the Boy Scout rule. If you see anything that smells, that has a code smell, you clean it up. And cleaning it up means you refactor it. That means you combine code into a separate method, you create new classes with dedicated methods where the new code is in, and you instantiate that from other classes. And all of that is more or less done on a daily basis. You start implementing something and then you start refactoring it. Somebody else starts refactoring it. You do pair programming and you do some refactoring afterwards. You do prototyping, you throw away the prototype, you still remember the implementation, and then you do some refactoring of the prototype implementation and stuff like that. Happens on a daily basis and breaks this approach completely, because the stack traces will be completely different every single time that you run your test cases. So while this is artificial intelligence, it learns a lot, but the problem is it doesn't understand how systems work and how people work and how programs work and how refactoring works. And therefore, it cannot do what it actually claims. It says, like, it leverages the power of machine learning. That's a given. It has machine learning implemented. in finding and prediction of fails. So it will find fails. That's true, that's a given, because the test case will fail, and there's a high chance that it will be able to identify, is that a problem in the test case, or is that a problem in the subject under test? But it will not be able to predict fails because of everything that I just told you. So the prediction is more or less based on the idea of, I know exactly how many problems happened in one area of the software. So if somebody touches that area of the software, the probability that a new error will be introduced in module X and Y, because they are related from the past, is X%. And that has nothing to do with artificial intelligence, again. So in those three examples that we went through right now, just to summarize those examples, you've seen that only one actually implements artificial intelligence. All of the others is just marketing buzzwords. So they use AI as a label to sell their solution. But here comes an interesting point on artificial intelligence and also autonomous testing. I mentioned the FDA, so the Federal Food and Drug Administration of the States. They have this idea of intent of use. And you need to provide that information for every single project, for every single software that you do in the medical field. So you need to write down what your user will actually use your software for and what they expect as a benefit from using your software. And that is interesting. If you think about this principle, you need to understand the intent of use to identify if a software works as expected. And that is universally true. If you don't understand the idea of a word processor, you never know if it is correct or not that you can enter text. It might be, if you assume that it's something completely else, it's a web page or whatever, you should not be able to enter text there. But for a word processor, you should be able to do that. So you need to understand the intent of use of the software you are going to use before you are able to test it. And that's exactly what all of us do if they test it. If they do exploratory testing, we talk to stakeholders, we talk to the customer, we talk to those guys that wrote the requirements, we talk to the developers, we talk to other testers, actually we talk to everyone to identify what is the idea of the software, how should I use it? And that's the problem for autonomous testing. If you think about the claim, like, we have full autonomous testing, what does that actually mean? That means you do have a piece of software A and a piece of software B. And the piece of software A can automatically test, completely autonomously, software B. And that means software A understands the intent of use of software B. And if that is true, so if A understands the intent of use of B, then we don't need to test at all. And that is my claim. So if there is a working autonomous testing platform, we don't need it at all, and we don't need testing at all. And I give you the reason why. If there is a piece of software A that understands the intent of use of software B, we do not need to write B anymore. We can tell software A, hey, this is my intent of use, please act like it, and the software will automatically act correctly to what I expect from it. And that is what autonomous testing actually claims, is like full understanding of the software. And everything else that you hear, like, yeah, but you need to train the software first and whatever, that is not autonomous testing. If I need to train my Tesla on how a traffic signal looks like, that is not autonomous driving. If I need to train it how a parking spot looks like, that is not autonomous driving. The idea is you enter the car, you set the destination, and off you go. That is autonomous driving. And it's exactly the same for autonomous testing. It's just like the problem space is far more complex for applications because There are multiple use cases. You don't know. In a car, it's pretty easy. You want to go from A to B, and there are a lot of roadblocks in between. That's a given. It's also complex, but a piece of software might act completely different. I mean, if I do have a word processor, it acts completely different to a spreadsheet. If I understand as a human how a word processor works, I have no clue on how a spreadsheet actually works. The same is true for a presentation tool like PowerPoint. If I know how PowerPoint works, I don't know how a word processor works. And that's the problem. It's not only one problem that software solves. Software tends to solve all of the problems. And to understand all of that requires a lot. And I hope you understand the chain of thoughts that I present to you. It's like, if we do have a software that can autonomously test, we don't need to test anymore because the software acts like the software that I want to have. And the last thing is like, where do I see the future of AI? And that is interesting because I think there is a tremendous future of it, and you can already see it. I mean, people are asking ChatGPT on, hey, please set up 100 test cases for me on the following system. If you go through those in details, you will see they are all generic test cases, but the system learns. So from some point of view on time, you will actually be able to generate specific test cases for stuff like where you say, I have a word processor and I need to have 100 test cases for the most common functionality found in the word processor. And the system will have the context of what is the intent of use of a word processor. That's a given. But if you have a specific application, let's assume you do have some blood typing robot that you need to test in an automated fashion. There is no common knowledge on that. So you won't be able to ask ChatGPT and say like, hey, I do have a blood typing robot and I need to have the 100 most common frequent uses of blood typing robots for my test cases. Please give me a list. You cannot learn that because it's not introduced to it. But one of the things that will come is like test data generation via AI. I mean, that is exactly where big data comes in. And big data and statistics is just a non-fancy name for artificial intelligence. Again, it's just algorithms. So what you see is like, we do have a huge pot of test data, which is our productive data. We are just not allowed to use it. But what we can do is like, we can train the artificial intelligence on the patterns in that productive data, and then ask the artificial intelligence to generate data that follows the patterns that it found in the productive data. And that will give us perfectly synthesized data to test from, with all the relations intact, with all of the different requirements over multiple tuples set correctly in the data set. So that is where I see the future for the close-term future for artificial intelligence is for sure in test data generation. And I can also imagine that you can use artificial intelligence for visual testing. So Applitools is already doing that in a way of comparing screenshots, but I guess that can go a few steps further, where you can actually train systems to identify for specific applications the different elements, and that the system can learn if the user interface changes, so that we reduce the amount of flaky test cases. Where I don't see it in the close future or in the midterm future is for test case generation for non-common things, like again, word processors or stuff like that. It's pretty trivial, but for a web page, you cannot ask the system like, hey, give me the test cases for a web page. The thing that you might ask is like, give me test cases for the login page of a web page, because that is specific. But the web page, there is no intent of use. So you need to provide the system the intent of use, and it needs to have something that it already learned from that had the same intent of use. So whenever you work with artificial intelligence, what you need to keep in mind, and if that's the only thing that you take away from this talk, I'm already happy, you need to keep in mind that, ask yourself, what is the intent of use of my software? And can my artificial intelligence understand that somehow? And I think that being said, I can close the screen sharing and see if there are any questions open right now.
Yeah, Hi again, Tobias.
You,
Very, very interesting. Very interesting. I have a question, and I personally have a question. So, but before I do that, I have a question here for you. It says, in what way can AI be used to enhance exploratory testing, and what benefit can this approach offer over more traditional testing methods?
Yeah, that's an interesting question. If you think about it, so what is exploratory testing? Exploratory testing is you as a human challenge the system. That is exploratory testing. You do that and you learn about the system. That is why you explore the system. You add additional knowledge. And my understanding from what I've seen on the market till today on how AI can support you with real exploratory testing is I haven't seen anything that enhances exploratory testing, to be honest. What you see is like stuff that it can take screenshots automatically if something happens on the screen so that you don't need to take it, but that has nothing to do with AI. It's just based on interactions with the target system. So real exploratory testing today is building up knowledge on the system, is actually building up knowledge on how the system behaves in different mode, and then identifying, and again, that is more communication task, identifying if that is correct or not. So right now, I cannot imagine a scenario where artificial intelligence, the way we currently have it, can enhance exploratory testing.
Yeah, well said. And that brings me to what I was about to say to you in thing, we hear a lot of talk about AIs and AI this and AI that. But at the end of the day, like you rightfully say, if you go to GTP, for instance, and say, give me code for a login test. What happens is I give you a generic piece of code that doesn't really have anything about it at all, and you now still have to actually pass in all the correct bits and pieces for it. And that is where, it builds up this whole thing. So, we say, and like you say, rightfully saying, on autonomous driving, the only place I've seen it is on the Jetsons. It's on the Jetsons. Exactly. It's on the Jetsons. You see the Jetsons, he gets up in the morning, it's completely autonomous. The bed wakes him up, the bed makes him and he don't have to do anything. It showers him, it bathes him. That is autonomous. But when I have to jump in my car and then besides tell it where I want to go, I still need to interact because it have a roadblock there for whatever reason. It didn't see that. Then it's not autonomous. It's not autonomous in any way. You have a little bit of AI built in, but the fact that they want to sell you full autonomous, it's just wrong. I mean, in these spaces,
and that is the point. What people need to understand is like and the thing starts already if you talk about level of autonomous testing. I mean, why do we have different levels of autonomous testing? It's more or less like a fake. I want to use the word autonomous testing, even so I don't provide the technology for it. So I call it autonomous testing level 2 or 3 or whatever. As long as I don't reach the full level or the final level of autonomous testing, it's all fine. And it's all of that is right now, it's just marketing. And you can see actually how far away we are. If you remember that example that I gave you, it's like it takes 15, 20 hours of driving lessons to understand how to drive. On any road, on the whole globe, in the whole world, it doesn't take much more. Yeah, you might do an accident at some point in time, but you know how to drive. And the full self-driving experience of Tesla, I mean, in how many parts of the world is it active? It's more or less like in the US, that's it. Everywhere else, you just have assistance systems. So after I don't know how many billion miles they already have, they still have no artificial intelligence that solves the problem of driving, a task that you learn within 15 to 20 hours. And yeah, I'm completely aware that there are 18 or 16 or whatever amount of years beforehand that you learn general knowledge about the world and how it works. But meanwhile, the Tesla artificial intelligence has over 12 years in development. So it's like, if you would have started when Tesla started the artificial intelligence program, by now you would easily be able to drive.
That's so correct. That is so true. And and I see the next question here. I mean, I could answer the question. It's the person want to know how they could find an AI testing tool that is capable of testing 501(k) medical devices along with the software.
Yeah, And the honest answer is I don't know. The FDA is currently or in the past actually changed their regulations on artificial intelligence. But there's also a new ruling that actually shows that you actually need to show that you are using artificial intelligence algorithms in the background if you claim that there is artificial intelligence involved, and you also need to show that there's a benefit that you use that. So I can look the answer up, but out of my mind, I can't tell you. I just know that it's actually extremely difficult because we wanted to do a medical device based on 510K, introduce that to the market with a dynamic scheduler, so something that actually learns based on how the user operates with the system, and the FDA actually blocked that. So I don't know. I guess I'm the wrong person to ask, to be honest, because I didn't succeed.
I guess that. I mean, that's really cool, and especially with the whole, the way they market it. It's a marketing tool, and people need to understand there's a lot of marketing that goes on into it.
Yeah, so that was the idea, Larry, of the talk. Is like everybody talks about AI and how brilliant it is and how much code it can give you and how everybody should be using it. And that's fine. It is a tool and you should use it. I mean, it's a new technology. You should use it, but you should be cautious of what is the result of it. And you should still be the one that is in charge of what is the result.
Yeah, I mean, I now I have more of a statement. And the statement here is, we should not fully rely on code AI generates, when it comes to automated scripts. And I think that's a fair enough statement to make. I think we should never fully rely on it at all.
Not today, and I guess not tomorrow. There might be some point in the future where that is actually true, because there is far more data in those models, and you have seen the changes. You have seen GPT-1, GPT-2, GPT whatever. ChatGPT is based on GPT 3.5, and now you have GPT-4, and you see the massive amount of data they put into those models, and you can actually see how it gets better and better and better. But the problem is, currently it doesn't understand. It's a statistical model with billions of data points in the background, which makes it look extremely fancy, but it doesn't have the understanding of what you even ask. And that's the problem. So the answer is no, you shouldn't rely. You shouldn't fully rely on that. Use it as a tool. Use it also if you write text, use it as a tool to give you some input. Use it to cross-check your code. Send your code into an AI review system, and if it finds problems, perfect. That's exactly what it's meant for. But don't rely on it.
Totally agreed. And this is a very interesting question, actually. It's a two-part question. Where does AI goes from here? That's the first part. And the other part is which programming language is not generally, this is a good one. That is a good one. Which programming language is not generally used in AI and why?
Yeah. So where does artificial intelligence go from here? I guess nobody tells you. If you ask Elon Musk, I've seen an interview with him like a few days ago. He says like, oh, it will rule the world within the next 4 years. But then again, in 2018, he said he will have full self-driving capabilities in his cars. Huh?
Exactly.
And honestly, I guess it's just, but that's my personal opinion. I think it's just another hype. So where will it go? It will see exactly the same wave that we've seen in the 60s and in the 80s. Right now, we just have a lot more compute power and we have a lot more storage. And that's it. That's why it's far more fancier right now. And it looks like pure magic. But that is just because we have a lot of compute power. So at some point in time, we will reach the point where the model is too big for the compute power that we have right now. And then people will go away from artificial intelligence again. And like 20 years later on or whatever, when we do have new CPU structures and stuff like that, and we have the next batch of even more CPU power, I guess we will get back to that. And at some point in time, we will have enough, and I guess that's no secret. At some point in time, we will have enough CPU power and we will have enough storage to actually rebuild the human brain. And once that happens, I guess artificial intelligence is here to stay. But that's not today, that's not tomorrow, and it's also not in 5 years from now.
Yes, exactly. And the other part of the question, again, I'll repeat it again, is which programming languages is not generally used in AI and why? if you know.
I don't know. I mean, there are a myriad of languages, isn't it? Like most of the stuff that I've seen is like Python is based. Most of the AI stuff is based in Python, just because it's a research language, or it started as a research language. So most of the universities and school use Python. So there are a lot of packages. I guess which programming language is not used at all? Honestly, I haven't seen anything in assembler that is used in artificial intelligence, because I guess that's a bit too hard. The same is true for, I guess, C# and like the typical functional programming languages. Also, if you would ask me how to start with artificial intelligence, I would tell you, like, use Python. You have the most tutorials, you have the most libraries, you have access to everything. Just use Python, and all of the other languages actually don't come close.
Exactly. And I mean, this is one of them topics that we could just go on and on and on forever talking about.
Yeah.
You know, but we're coming to the end of the session, so we have a couple of minutes. If anybody have any other question they want to throw in there, you know, I would ask, push it on to Tobias. But again, Tobias, I mean, in the meantime, when we look at the whole AI, I mean, especially in the world of test automation, we realize that there are parts of it that you could put inside of a framework and get it to do little things like maybe write your Gherkins, your Gherkin scripts for you. But that in itself as well, and I mean, this is from experience, that for yourself, it says, gives you one of these generalized thing and nothing to actually specifically do with with the application at hand. You still have to go and rejig it. So it's all about how we should, I would say it's like this is about, you can use the tool to generate that and then use that as a layout to formulate all your follow-on test cases. What do you think about that?
Yeah, that is more or less exactly what we do, actually, Larry. It's like we're also looking on how we can employ artificial intelligence in testing, in test automation. And one of the pieces that we do is like we focus completely on visual cues. So we automate the complete user interface just based on what we see on the screen, and simulate a human user based on that. And what we do there is also some autonomous testing, but it's not really testing. But what we do is we understand how a microsystem actually works, like a drop-down. You can imagine there's a drop-down, you can click on it, then there will be some space that unfolds, there will be a list of elements in it, it might be scrollable, and stuff like that is more or less like, it's a simple enough problem to teach an artificial intelligence on how a drop-down actually works. And then you can reuse that in your scripts. But the actual process, so the knowledge on the combination of the elements in the software, that is something that I right now don't see that will come in the next 5 years.
Yeah. Well, I mean, I think we kind of out of time in this sense, and I wanted to thank you for taking the time out to do this and pass the knowledge on. And
hey, thank you very much for
everybody. Thanks to ZappleTech for giving us the space, to do this. Really want to applause to ZappleTech for that. And and we will do a lot more of this, coming up, because this especially in this particular area, because this is a big area, because it's everything you look at now talks about about the whole AI and things like that. So yeah, thanks again, and for everybody on the call. This talk would be live. It is being recorded, and it will be on YouTube later on today, so that you could go back and look into it. And if you have any questions for Tobias, I'm sure put up your details, and so people would reach out to you and ask and I'm sure about that.
Sure. Hey, thank you very much, Larry, for having me, and thank you, ZappleTech, as well for organizing all of that.
Yeah, thanks. Thank you so much, Tobias.